Hello everyone, welcome back to Physics and Maths with the Dr. S.K. John YouTube channel. This is the third lecture of the series on differentiation. Today we will learn how to differentiate implicit functions. Before that, I will explain what are implicit functions. The functions which are not directly expressed in the form of y is equal to f of x, but obviously y depends on x are known as implicit functions. So, in the previous cases, we differentiated many functions like y is equal to sine x or y equal to some x cube plus 3 or y is equal to some any other function e raised to x plus sine x like this. In all these functions, y is expressed as a function of x. Okay, on the left hand side you have y, on the right hand side there is a function of x. Okay, so these are called these functions clearly shows the relation between y and x. Okay, and it is expressed in the form y equal to f of x. But see these functions x minus y equal to pi, y plus sine y is equal to cos x, x plus sine xy minus y equal to 0. These are some examples of implicit functions. In these functions, it is very clear that x and y are related. X and y are related, but it is not written in this form y equal to f of x. It is not written, it is not expressed in this form y equal to f of x. Some functions like the first one can be converted to that form. Clearly, here you can write y is equal to, if you take y to the right hand side, y is equal to x minus pi on the left hand side, x minus pi. And so now it is in the y equal to f of x form. Okay, but if you look at the second and third ones, here you cannot easily write these functions because uh, you cannot easily write these functions in this form y equal to f of x. It is very difficult because the y is there in the argument of sign. Okay, so we cannot easily take out y and write in this y equal to f of x form. Here also you can see that we cannot easily find y in terms of x. Okay, so these are the functions. Okay, or all these functions are implicit functions. Okay, that means the relation of x and y is very clear or it is evident, but it is not easy to, in some cases it is not easy to express y in terms of x, but in the other case, but in some cases we can write y in terms of x. Okay, anyway, when these functions are given as relations between x and y or in the form of equations, we say these functions are implicit functions. Implicitly they are functions of implicitly they shows the dependence of y and x. They are clearly they are depend y is dependent on x, but it is not expressed in the form y equal to f. These type kind of functions are known as implicit function. Usually they are given as some equations. Okay, now coming to how to differentiate implicit functions. I will explain this differentiation of implicit functions based on these three examples. After that, we will do uh, the questions which are given in the exercise, NCERT exercise 5.3. 5.3. Okay. There are 8 questions given in the NCERT exercise 5.3. We will solve all those questions. And there are some more questions which are related to the inverse functions. Using the idea of implicit functions, we can differentiate inverse functions also, some complex inverse functions also. Um, those problems I will do as another video. Okay. Otherwise, this video will be very lengthy. Okay. Let us start solving these questions. The first example is, if x minus y is equal to pi, then find dy by dx. So let us write the given implicit function x minus y equal to pi. What we have to do is directly differentiate these functions. When you differentiate x, you will get 1. Now what is the derivative of y? the derivative of y is dy by dx. Okay, the derivative of x is 1, d by dx of x is 1. Whenever you differentiate y, you can write it as dy by dx itself. Okay, and this is pi. The pi is a number, so 3.14 or approximately 22 by 7. uh, so its derivative is 0. So differentiating, we have to write this: differentiating with respect to x, with respect to x. Okay, this is the short form of with respect to, with respect to. Okay, with respect to x, the derivative of x is 1 minus the derivative of y is dy by dx is equal to the derivative of pi is 0. So we will get dy by dx is equal to 1, and this is the answer. Okay, now going to the next question, next example. Here the implicit function is, or implicit relation is, sine y plus sine y is equal to cos x. So differentiating with respect to x, the derivative of y is dy by dx. Now what is the derivative of sine y? uh, Here you have to use the chain rule. First you have to differentiate sine. The derivative of sine is cos, you know, so you have to write cos y. Okay, the derivative of sine y is cos y, but you have to differentiate y also. What is the derivative of y? Dy by dx. So you have to write as a function of function rule or chain rule. Function rule means chain rule. This is a composite function. Okay, so first you have to differentiate sine, so you have to write cos y, then you have to write multiply it with the derivative of y. So cos y into dy by dx, this is equal to, what is the derivative of cos x? It is minus sin x. Now the next step is, here you have dy by dx in two terms. This term contains dy by dx, this term also contains dy by dx, so you have to take dy by dx out or in common. So dy by dx is common. By taking it outside, we get, here it is 1 and here it is cos y. The next term it is cos y, that is equal to minus sin x. So finally what is dy by dx? Dy by dx is equal to minus sin x divided by 1 plus cos y. So this is our final answer. Now going to another example. Again I am writing this relation: x plus sin xy minus y equal to 0. Differentiating with respect to x, we get, what is the derivative of x? It's 1. What is the derivative of sin xy? Here it is a product, sine of xy. So first you have to write cos of xy, then you have to differentiate xy. Now xy is a product, so you have to differentiate it using the product rule. First function x into derivative second dy by dx, plus second function is y into derivative of first, it is 1. Derivative of x is 1. Okay, derivative of xy, what is derivative of xy? I just repeat: x times dy by dx, derivative of y, plus second function to derivative of x is 1. So this is the derivative of xy. Okay, now this part is over. Then minus y minus dy by dx equal to 0. Now I will open the bracket, 1 plus cos xy into this term. So that is x cos xy dy by dx, plus cos xy into y. So y cos xy minus dy by dx is equal to 0. Now the next step is, you can see dy by dx in this term, also in this term. So you have to take dy by dx common. Dy by dx times x cos xy plus, not plus, it's minus 1. Okay, this term and this term. That's equal to, I will take the other two terms to the right hand side. To the right hand side. So it is minus 1 and minus y cos xy. Okay. So what is dy by dx? This term divided by this term. Okay. I will take the minus outside. So 1 plus y cos xy divided by this term. I'm writing this term as minus of 1 minus x cos xy. Okay. Uh, this is like a minus b. I am writing as b minus a. Then I will get a minus sign out. And those two minus sign will cancel each other. And final answer is 1 plus y cos xy divided by 1 minus x cos xy. This is the final answer of this question. I think the concept is clear to you. Now we will solve the remaining 8 problems in the exercise, which are in this form: implicit functions of x. Okay, solution of this equation. I'm writing this equation again, equal to sin x. Now differentiating with respect to x. Differentiating with respect to x. Differentiating with respect to x on both sides. Differentiating both sides with respect to x. 2 times the derivative of x is 1 plus 3 times the derivative of y is dy by dx is equal to the derivative of sin x is cos x. So keep the term containing dy by dx on the left hand side. This term which does not contain dy by dx can be taken to the right hand side. So you will get cos x minus 2. So dy by dx is equal to 3 can be taken to the right side. So cos x minus 2 divided by 3. Okay, this is your answer. Now coming to the next question. Here there is only one difference. In the previous question it was sin x here. In this question it is sin y. So we are going to solve this question. 2x plus 3y is equal to sin y. Differentiating this implicit function, differentiating both sides. In all implicit functions we have to write like this: differentiate both sides with respect to x. We get 2 times the derivative of x is 1 plus 3 times the derivative of y is dy by dx is equal to the derivative of sin y is cos y, and here we are differentiating sine, then we have to differentiate y also. The derivative of y is dy by dx. When it was in the previous problem it was sin x, then its derivative is simply cos x, because the derivative of x is 1. Okay, so we have to multiply, we are multiplying it with 1, that is why it is same as cos x. Okay, but here the it is sin y, the derivative of y is not 1 because we are differentiating with respect to x, so the derivative of y is dy by dx. Now we have to take this term containing dy by dx to the left hand side. So 3 dy by dx minus cos y dy by dx. This term is taken to the left hand side, and this term which does not contain dy by dx is taken to the right hand side. So taking here dy by dx is common, so you can take it outside. Dy by dx into 3 minus cos y, it is equal to, and dy by dx is equal to 2 divided by 3 minus cos y, and this is the final answer: 2 divided by 3 minus cos y. Okay, now coming to the next problem. Find dy by dx if ax plus by square is equal to cos y. Ax plus by square is equal to cos y. This is the implicit function or implicit relation given. Now differentiating both sides, differentiating both sides with respect to x, we get a times the derivative of x is 1 plus b times the derivative of y square is 2y. The derivative is y square is 2y times dy by dx. Okay, here we have to differentiate the square, then it is 2y, then we have to differentiate y. The derivative of y is not 1, it is dy by dx. Okay, equal to cos y. The derivative of cos y is minus sin y. Then you have to differentiate y. Firstly, we are differentiating cos, so it is minus sin. Then we have to differentiate y. It's dy by dx. So grouping the terms of dy by dx to left hand side, dy by dx times, here it is 2by. On the right hand side we have minus sin y. When it is taken to the left hand side, it will be plus sin y is equal to, this term goes to right hand side. The term which does not contain dy by dx goes to the right hand side. So dy by dx is equal to a divided by 2by plus sin y. So this is the final answer. Now coming to the next question. The method is same for all questions, but you have to practice each and every question. Then only you can master the differentiation. Otherwise, you will get confused at some terms. So practice these questions. We are going to solve this question. The given implicit relation is xy plus y square is equal to tan x plus y. Now differentiating both sides of the above equation with respect to x. Here this is a product, so you have to use the product rule. X times the derivative of y is dy by first function to derivative second plus second function y into derivative first is 1 plus the derivative of y square is 2y dy by dx. Okay, the derivative of x square is simply 2x because the derivative of x is 1, but here it is y square, so its derivative is 2y times the derivative of y. We have to multiply with the derivative of y, which is dy by dx. In the case of x, it is dx by dx. D by dx of x is 1. This is 1, so 2x into 1 it equal to 2x. Here it is 2y dy by dx. That's equal to the derivative of tan x is sec square x plus the derivative of y is dy by dx. Now we have to group the terms containing dy by dx. Which are the terms containing dy? This is one term, this is another term, this is another term. So if we take dy by dx common, there is one term on the left hand side which is x, another term on the left hand side which is 2y, another term on the right hand side is plus dy by dx. So when we take dy by dx out, it is minus 1. When it is taken to the left hand side, it will be minus dy by dx, so it is minus 1. This is equal to the term without dy by dx is y. I am taking that term to the right hand side, so it becomes minus y. Oh, one more term is that it is sec square x, sec square x minus y, then sec square x minus y. This term is taken to the right hand side, sec square x minus y. This term is taken to the left hand side. Okay, x plus 2y minus 1. Okay, it's okay. Dy by dx is now sec square x minus y divided by x plus 2y minus 1. So this is the final answer. Coming to the next question, find dy by dx if x square plus xy plus y square is equal to 100. So I am writing the equation down. X square plus xy plus y square is equal to 100. Differentiating both sides of the equation with respect to x, we get the derivative of x square is 2x plus the derivative of xy. We have to use the product rule. First function derivative of second plus second function is y, derivative of x is 1 plus what's the derivative of y square? It is 2y dy by dx. That's what is the derivative of 100? 0, because it's a constant. Now we have to group the terms containing dy by dx. So it is x dy by dx and 2y dy by dx. So if you take dy by dx outside, it is x plus 2y inside the bracket. And the other two terms can be taken to the right hand side. It is minus 2x and minus y. So dy by dx is equal to, on the right hand side there is minus sign on both the terms, so I will take it outside. 2x plus y divided by x plus 2y. X plus 2y. Okay. So this is our final answer. Now coming to the next question. Here there are four terms. I will write it again. X cube plus x square y plus xy square plus y cube is equal to 81. Differentiating both sides of the equation, both sides with respect to x, we get, what is the derivative of x cube? It is 3x square. We have seen it before. It's like 3x square plus, what's the derivative of x square? You have to use the product rule. First function derivative second dy by dx plus second function is y, derivative of x square is 2x plus, for the second time also we have to use the product rule. First function derivative second is 2y dy by dx. The derivative of y square is 2y dy by dx plus second function to derivative x is 1. So two product rules here plus the derivative of y cube. What will be the derivative of y cube? It will be 3y square times dy by dx. Derivative of y square is obtained using the formula nx raised to n minus 1. So we can put 3 into x raised to 3 minus 1. The derivative of x cube is 3x square. So the derivative of y cube is 3y square. And for y we have to write dy by dx. And on the right hand side it's a number, so derivative 0. Now we have to group the terms containing dy by dx. There are three terms. X square dy by dx is this term. Then we have 2xy dy by dx. Then we have another term plus 3y square dy by dx. On the right hand side, we can take all other terms to the right hand side, minus 3x square, or we can write minus of 3x square, and this term also is minus when taken to the right hand side, 2xy. We have this term minus y square. Sorry, all the terms becomes plus because I have taken minus outside. Those three terms. Okay. And here you can take dy by dx outside, and you can write x square plus 2xy plus 3y square. That is equal to minus of 3x square plus 2xy plus y square. So dy by dx is equal to, the final answer is dy by dx is equal to minus of 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. This is the final answer. Okay, now two questions are remaining. If sine square y plus cos xy equal to k, then find dy by dx. Sine square y plus cos xy. This is a product cos of xy. That is equal to k. Find dy by dx. Therefore, differentiating both sides with respect to x, we get, what is the derivative of sine square y? First, we have to differentiate the square term. First, we have to differentiate the square term. So it is 2 sine y. It's a composite function of x square, then sine x, and then uh, x square and sine y. X square and sine y. Composite function of x square and sine y. So when we differentiate the square, actually the sine square y is the square of, it is sine y the whole square. So first we are differentiating the square. So 2 sine y. The derivative of x square is 2x. So sine y square is 2 sine y. Then we have to differentiate sine. When we differentiate sine, it is cos y. Then we have to differentiate y, it is dy by dx. Okay, so this is the derivative of sine square y is 2 sine y into cos y into dy by dx. Plus here we have cos xy. For cos we have minus sine xy. Okay, then we have to differentiate that xy. What is the derivative of xy? X dy by dx, product rule, plus y into 1. On the right hand side we have a constant, so the derivative is 0. Okay, so the first term, what is this term? We have seen it before. 2 sine y cos y is, by formula it is sine 2y. Okay, you have to study the formula if you don't remember it. You have studied it in class 11. 2 sine y cos y is sine 2y. So sine 2y divided by x minus, here we can open the bracket. So minus sine xy into x divided by x. I will write it in another form. X times sine xy divided by x minus sine x minus y sine xy minus sine minus y sine xy, when we open the bracket, equal to 0. These two terms contains dy by dx, so we can group the dy by dx into sine 2y in this term, and here it is minus x sine xy. So this is equal to y sine xy. This is taken to the right hand side, so it becomes positive. So final answer is dy by dx is equal to y sine xy divided by sine 2y minus x sine xy. So this is the final answer. Coming to the last question of this video. Solution. I'm writing the equation again. Sine square x plus cos square y is equal to 1. Differentiating both sides with respect to x, we get the derivative of sine square x is 2 sine x. 2 sine x. Sine square x is sine x the whole square. So first we have to differentiate the square term. The derivative of x square is 2x. So the derivative of sine square x is 2 sine x into then we have to differentiate sine. The derivative of sine is cos. It is a chain rule. The derivative of sine is cos x. Yes. The derivative of x is 1. So it's okay. 2 sine x cos x plus, here it is cos x cos y the whole square. Cos y the whole square is written as cos square y. Cos y the whole square. So first we have to differentiate the square. So 2 cos y. Then we have to differentiate the cos. Cos y, the derivative of cos y is minus sine y. Then we have to differentiate y. The derivative of y is not 1, it is dy by dx. And on the right hand side, we have 1. What is the derivative of 1? It's 0. Now if we simplify, what is this quantity? It is 2 sin x cos x is sine 2x. So sine 2x plus, what is this quantity? If you take the minus outside, what is this quantity? It is 2 cos y sine y, or 2 sine y cos y, that is sine 2y. Sine 2y dy by dx equal to 0. So sine 2y 2x is equal to sine 2y dy by dx. Okay, so dy by dx is equal to sine 2x divided by sine 2y. So this is the final answer. Okay, so in this video we explained what are implicit functions. They are the functions, the relations of x and y, but they are not expressed in the form y is equal to f of x. And we learned how to differentiate these implicit functions. We did the related questions from exercise also. Okay, thanks for watching.